Welcome to this introductory video on how to use UndoDB. Today we'll be showing the basic functionalities that UndoDB provides. Emacs is a feature-rich editor that integrates an IDE-like interface for Gdb that can be used by UndoDB. Before starting, let's make sure the configuration file contains the following expression. Let's launch Emacs and set up the interface. The first thing to do is to fire up Gdb and change the command to look like this. Gdb supports an optional mode of operation in which you can examine stopped program threads in the debugger while other threads continue to execute freely. This is referred to as non-stop mode. Emacs has a setting for it called Gdb Non-Stop setting. UndoDB doesn't support non-stop mode, so we must be sure it is disabled in Emacs. To know how to make this change permanent, take a look at the documentation, How to install UndoDB in Emacs, listed at the bottom of the page. The following command allows us to set up Emacs to have the IDE look that we want. Let's execute the command gdb many windows. Let's start the program. If Emacs didn't already load the program, it should now show the source code and position the cursor at the beginning of main. It is a good idea to have a breakpoint in main in case we need to replay our software backwards. We can now execute the program and see what happens. The program threw an exception. Let's debug it. First, let's go back to the point where the exception was thrown. To do that, let's set a breakpoint in the operator function inside the cache tester class. And let's reverse continue to that point. Let's double check the value of the variable called number. And then type next to execute the next line of code. This will verify square rooter returned value 0. Square root cache should now be 0. The value is already displayed here. Okay, that is definitely wrong. We can go backwards and see what happened inside square rooter with reverse step. This shows we are actually at the end of square rooter as line 55 is the closing bracket of the function. Let's keep going backwards to see what the return value is. So the value is being found in the cache. Let's confirm it. Because we are always calculating two square roots when given a number not in cache, let's take a look at the preceding and following values inside our cache. When we scroll, we can see that the value before 255 is 210. And the following is 0. Because 255 is the first number of the pair, we can now add a conditional breakpoint to go backwards until we calculate the square root of 0. We need to remove the breakpoint on line 90 before continuing. Now we can go backwards until the variable number will be equal to 0. Note that RC is the short version of reverse continue. Other commands such as reverse next have similar short forms. As expected, number 2 is -1. So why does it show as 255? What type is the variable called data? So we have found the issue. We pre-cache nearby square roots. The lack of a boundary check means that we attempt to prefetch the square root of -1, whose square root is not a number. This is cast as -2 billion for a signed integer, which in turn is cast to 0 because data accepts pairs of unsigned char. Number 2's value of -1 is similarly cast to 255. Just to recap what we've learnt in this demonstration. We've learnt how to start a program, how to set breakpoints with and without conditions, how to continue the program forwards and backwards, how to execute one line forwards and backwards, how to print the value of different variables. Of course, if any of the commands used here were not clear, it is possible to use the help command inside UndoDB or the man pages that come with the UndoDB package. Thanks for watching. For more information, visit the Undo website at undo.io.